What's up, AP Psych? This is your lecture on sleep and dreams. This is one that people tend to throw a ton of questions at me for, but most of them are based on social media myths. I mean, I'm happy to take those questions in class, but this lecture will focus almost 100% on facts, as much as I can, and specifically what you need to know for this class. So all that other stuff, feel free to jot it down and we can discuss in class if you are curious more about sleep and dreams. Here are our learning targets, and here we go. The first important term you need to know is circadian rhythm. Circadian rhythm is the body's natural 24-hour sleep and wake cycle. Some studies show that our sleep wake cycle on our own is closer to 25 hours, but there's so many natural interruptions in our sleep, like alarm clocks and the need to go to work, the need to go to the bathroom, things like that, that we tend to operate mostly based on nature's 24-hour sleep wake cycle, despite our body's desires to get just a little bit more sleep. Our circadian rhythm responds to light signals to the suprachiasmatic nucleus, the SCN. I don't actually think you need to know that. I just think it's kind of a cool word. And the pineal gland. And it tells the body when to release sleep hormones, things like melatonin and GABA, our natural levels of melatonin and GABA. And so when it's light out, like you'll see behind me, the sun is up. It's kind of a cloudy day, but the sun is still out there today. It's still light out. It's about 3 in the afternoon when I'm filming this. And that light signals, and just like the light in our homes, signal to stop our body to stop releasing melatonin. Don't make someone feel sleepy. Melatonin falls under the category heading. I'm going to sneeze. Hold on a second. Whew, I just thanked my medulla for helping me sneeze. Anyways, on the other hand, when it is dark out, there's no signal stopping the release of melatonin. And so our melatonin levels then on their own increase and make us feel sleepy. So you should also notice that or have a critical thinking moment. Hopefully, you're having a personal connection moment of, oh, so when I stare at my screens late into the night, that is giving off light and it's stopping the signal to my body to release my melatonin, and therefore I'm staying awake longer than I should. Yes, that is the connection you should be having right now. Darkness triggers sleep. So if you're having trouble sleeping, it might be because you're looking at screens too late into the night. Okay. Anyways, we'll talk more about that in class. The quality of our sleep is deeply impacted by our sleep routines. Our body will learn our light and dark routines based on when we typically go to bed and when we typically wake up. And even if we're not getting enough sleep, if we follow that routine, for the most part, the quality of our sleep will be better and we will feel that we are better rested during the day when we follow a routine. It also does not take long for our bodies to get off routine. So even one Saturday of staying up late or one Friday and Saturday staying up late could still make us feel extra groggy on a Monday morning. You might also notice that even though you can sleep in, your body, especially on a Saturday morning, your body might naturally wake up when your alarm clock has gone off at the same time Monday through Friday, even though you're like, no, it's Saturday, I don't need to wake up. The average person would sleep 9 to 10 hours if left uninterrupted, but it is true that adults need less sleep than teens and children, and this happens because of the way our body repairs itself and our brain development while we sleep. More on that to come. One other fun trivia fact: we will spend 1/3 of our life. Researchers, with the help of EEG machines, have determined that most people, your average person, follows a sleep cycle or kind of a pattern of brain activity. These are EEG readings that show a pattern of brain activity throughout our night. If we are awake, we will see beta waves or alpha waves that look like this. So in other words, our brain is very, very active. And then as we fall into sleep, those waves get bigger, slower, more spread out. And then you'll notice that REM sleep, which is the dream stage, is almost as active. Our brain activity is almost as active as when we are awake. So our sleep cycle, we actually fall down into deeper levels of sleep and we then go back up into more active stages. And when we hit REM, we are dreaming. When we have a non-REM stage, that means non-rapid eye movement, more on that in your notes to come. It means we are not dreaming and different things happen to us at different stages. Let's take a look at those stages. In stages, non-REM stages 1 through 3, this is considered quiet sleep. Quiet because we are not dreaming. In non-REM stage 1, this is a brief sleep. You're briefly drifting off to sleep, perhaps even going just a smidge deeper than a daydream. These are brief, 5 to 10 minutes long. You may experience hypnagogic sensations. These are fantastic images, fantastic, not like, way to go, fantastic, but like fantasy images that aren't really there. Perhaps you feel a sensation of falling, floating. Maybe you even hear noises that cause you to wake back up. It's very easy to wake someone up from this stage, though you might feel like you experienced a dream because of these fantastic images, like hallucinations, things like that. Then, as you fall deeper into your sleep, you will hit stage 2. This non-REM sleep, stage 2. This is what you would hope to get to if you had to take a power nap. These are about 20 minutes long. You are more relaxed. You are clearly asleep. Both your breathing and your heart rate dropped, not to anything unsafe, but slow you down. However, you might still have little bursts of activity that we call sleep spindles. These are short bursts of brain activity that appear on EEGs. So it means, yes, you're asleep, but your brain might have little moments of activity. So you might feel again like you're experiencing little short dreams, and it might not be quite as deep of a sleep as if you were falling asleep for the entire night. Um, okay. Then we get to stage 3 or non-REM stage 3. This is your deepest sleep. This is the sleep where it would be the hardest to wake you up. If someone woke you up, you would feel extra groggy. It might really startle you to be woken up out of a stage 3. And it only occurs during the first few cycles of the night. Eventually, you'll see on a different slide that this stage actually gets a little bit shorter to allow for more dreaming. This stage is considered very good for the body. This is a stage where growth hormones are released. It stimulates development of your brain, helps repair muscles and tissues in this stage, boosts your immune system, things like that. It will last about 30 minutes. And then the good stuff. And the good stuff is REM sleep, rapid eye movement sleep. This is when you dream. And it's the good stuff because this is really good for the mind. This helps strengthen your memory. This helps reset your brain for the next day. And good REM sleep is often what leaves you feeling the most rejuvenated and alert the next day. REM sleep is also considered paradoxical sleep because your brain appears awake, as you can see in this EEG image, but your body is technically asleep, and so much so that your muscles are actually paralyzed. Now, I don't mean paralyzed forever, but while you sleep, your muscles are paralyzed to protect you from accidentally acting out your dreams or reacting to this extra brain activity. So your brain is resetting itself for the next day. Your muscles are stiff and combined. If you combine this as good for your mind with stage 3 as good for your body, quality sleep will make you feel rejuvenated both physically and mentally. If we don't get it to the point of REM sleep enough in a given night, we actually might get more of it the following nights. So that's something called REM rebound. This is increased amounts of REM after being deprived of it on earlier nights. So our brain really strives to hit our REM sleep cycle or stage of the cycle. And so if we don't get enough of it one night or in a series of nights, we might dream more in the nights after that. And everybody dreams. Even if you don't remember your dreams, even if you never remember your dreams, everybody dreams. We will go through this graphic again in class, but basically this is going to demonstrate what I was saying about certain stages, stage 3, kind of getting shorter or disappearing entirely throughout the night to have an increased amount of dreaming throughout the night. So one of these series of ups and downs is about 90 minutes long. And what happens is that these deeper stages shorten. You can see stage 3 get shorter and shorter and shorter until it goes away completely. And the reason our body does that is it then allows more time to be spent in REM. So our body is going to be more rejuvenated from the first half of our sleep, and then our mind is more likely to be rejuvenated with the second part of our sleep. So if you aren't sleeping enough, your body might be okay, but your mind, you might feel a little confuzzled that day or just not feel like you can think clearly. For those of you, as I was saying, for those of you who think that you don't remember your dreams, it's possible that you're not getting enough sleep and so you're not hitting enough REM. But if you very vividly remember your dreams, most likely you've woken up pretty close to a REM cycle and you're going to dream all night long, but you're only going to remember the dreams that occurred probably close to when you woke up. Should we nap? Gosh, isn't this a great topic? In a word, yes. Our bodies will strive for a major sleep at night. Our body needs that. But then 12 hours later, after the middle of our main sleep, our body will want another little sleep. I will help you calculate this in class, but essentially kind of lets you in on why you get really sleepy at the same time of your day every day. If you do get the opportunity to nap, a 45-minute cat nap improves alertness for up to 6 hours, but if you nap for longer than 45 minutes, that might mean you're not getting enough sleep during or enough quality sleep during the night. So put those screens away. Okay, why do we sleep? There are two theories, and just like so many things in this class, the answer is not one or the other. It's most likely both. Why do we need sleep? For repair and restoration. This theory states that sleep helps our body go back to a state of equilibrium, both in the mind and the body. We spend less energy on activity, and then sleep allows more of that energy to be spent on repairing the brain and the body tissues from daily use. Sleep will help us re-energize our body and restore our immune system. So if we're not getting enough sleep, it makes us more vulnerable to colds and viruses and things like that because our body is not strong enough to fight them using our immune system. Sleep also contributes to memory consolidation. Sleep helps transfer newly encoded memories to become long-term. So when we sleep, our brain is sorting through all of the experiences of the day and kind of sorting through what do we need to keep and what could fade away. While we're sleeping, there's less interference from constant stimuli of information flying at you, and your brain can focus more on locking in new information. In a nutshell, sleep helps rebuild, strengthen fading memories, or perhaps it will allow certain memories to fade. Pro tip, it is actually to your advantage to sleep right after studying to help those memories get consolidated without any other interference between the end of studying and going to sleep. We'll talk about that more when we do the memory unit. Our final topic are sleep disorders. There are many, many, many sleep disorders. We are only going to focus, I think, on 5 of them. The first one is insomnia. This is difficulty falling or staying asleep. This is very common in the modern era. It is often linked to chronic stress or an irregular schedule where you're going to sleep and waking up at different times every day. Sometimes it will happen due to alcohol or stimulants, caffeine, things like that. It is the most common disorder, as 1 in 10 adults will experience insomnia at some point, and 1 in 4 elderly adults will experience insomnia. Next, we have narcolepsy. These are uncontrollable sleep attacks. They might even happen while someone is talking or standing up, and it is often that a person falls instantly into REM sleep, which is why they'll fall down. Because if you remember, in REM sleep, your muscles become paralyzed, and so your muscles are weak, and then you might collapse. Typically, these attacks only last for about 5 minutes or less, and they might appear like a seizure. The third one is REM behavior disorder, or RBD. This is when your muscles are not paralyzed in REM sleep like they're supposed to be, and it allows a person to act out their dreams. This is different than sleepwalking. We'll talk about that in a second, because this is happening during REM sleep. And so you might fall out of bed. It is possible that you might even hurt someone if you are acting out your dreams. So your muscles are supposed to be still, and if they're not, you might experience REM behavior disorder. Next is sleepwalking, also known as somnambulism, another word that I am not good at pronouncing. And this is when you are moving in a slow automatic manner while sleeping. This happens in stage 3, not REM sleep. So your muscles are not paralyzed, but your brain is supposed to be in such a slow pattern that you wouldn't want to get up and move around. But this does happen anyways, and that's what makes it a disorder. This is most common in children. Common activities are eating, getting dressed, or possibly going to the bathroom or trying to while you're supposed to be sleeping in stage 3. Finally, the last one we need to know is sleep apnea. This is the failure to breathe for moments when asleep. So in other words, like your breathing, here's my image. Your breathing passageway gets closed off. This should be open. And so because of the nature of the way your head is lying, your breathing way gets cut off. And often the inability to breathe will wake you back up. And then a lot of times you fall back asleep, and this will repeat over and over and over throughout the night. There are treatments for sleep apnea, most commonly weight loss or getting a CPAP machine. I can't remember what all that stands for, but it helps force air through your breathing passageways even while asleep. And it looks something like this. And a few minutes ago, when I said we had one last topic, I meant about sleep. We have one last main topic, 2 more slides to go, and that is about dreams. Dreams, of course, are these stories that go on in our mind while we are asleep. Sometimes we can remember them, sometimes we cannot. And while sometimes they feel very real, they tend to be more bizarre and unrealistic than real life would allow us to experience. So most commonly, dreams have some degree of likeness to daily activities. We have 3 theories as to why we dream, and we do not in psychology consider dreams to have meaning, because that would imply that we can prove that. There is no way to prove that dreams have meaning. So in this class, we say that they do not, but they still do 3 different things for us. They help us. One theory is that they help us sift, sort, and fix the day's experiences into our memories. That our dreams are actually different images of real life and hypotheticals that are really just us trying to process our memories. We call that theory information consolidation. We also think that dreams are helping our physiological and cognitive development, that our dreams are providing our brain stimulation to help us develop neural pathways and thinking. So there's definitely some overlap here with our memories, but that our brain is really developing and firing off neurons or resetting our neurons, which throwback to what I said earlier, this is also the theory as to why young children and teenagers need more sleep than adults. And then the final theory is activation synthesis theory, that the brain creates stories out of random neural activity in the pons, the hippocampus, the temporal lobes, and association areas. And dreams are just that. They are random images firing off while our brain is just firing in whatever way it wants to, in absence of other normal mental stimulation. And no one theory on its own explains dreams, so most likely the answer is a little bit of all of these things. And it's not actually the spirits trying to tell you something, but I know some of you will believe that no matter what I say. All right, that's it.